Hi, my name is Mohammad Hamza Imran Sayed, and I'm here to present my Big Data Technologies Assignment 1. So, this is a 10-minute video, so we have short time and we will go through the things. First of all, we were given the raw tweet data set in which we have to perform some data pre-processing in order to get the clean tweets so we can perform some MongoDB queries on that data. So that's the ingest file that I have written to clean my data. And in my ingest file, we were facing some problems in which mixing raw objects, ISO data, and number lang, even comments headings was treated as the tweets. So this particular file help us clean that data and then transform the top objects in which we will have some sort of clean tweets and then further clean that into the clean tweets file, and then that file is sent into the MongoDB. So there we can perform this. The script of this is shared on the island. So here we go to the MongoDB. The original file had around 43,000 tweets in that, but after cleaning we got 10,000 tweets and we got 7,700 near users. So let's move to the query part. In the first query, we were asked to find the emerging hashtags of some users. So this is the pipeline I made for the first query. As you can see that the output is coming here. And in the second query, here is the second query. You can see the result for the second query here. In the second query, we were asked to, let me just go through that. Yeah, in the second query, we were asked to find the coordinated link burst for the less than or equal to three distinct users who were posting within the last 60 minutes. So when we ran this query, we get these group of users who posted in the last in 1 minute, same 1 minute on any of the given date. So moving on to the next pipeline, the part 3 one. Yeah. So in this query, we are asked to find the high volume near duplicate per user who post less than equal to 5 tweets a day. So in our clean text, we have this group of users who have posted two, and if we go to the 3 tweets, we will find these type only one user who have posted three, but there are not more than three in our clean data. So moving on to the next part, in part yeah, that's the part C of section A, in which A part we are asked to perform the socket puppet signals, the intersection base, the pair of first users who share their location or they have the same domain URL. Let me go through this pipeline as well. Yeah, so this is the pipeline for this, and yeah, these are the results for this pipeline. You can see these two users have the same domain and they have tweeted something. And this is our last pipeline, but unfortunately I tried to do that, but it isn't giving any output. So I tried to run this query on the other data as well. Sometimes it was giving any answer, but sometimes it's not, but it's not giving on my clean data. Let's move to the next part. So next part is the section B, which is graph database, in which we have to design the first model on the Neo4j, and then we have to justify and test that model. This is our Neo4j model that I designed, and here you can see we have 49,891 nodes. We have 2,55,710 relationships, and if we go, let me just go through the models. Here are some of our relations in the model. Here are some of the nodes, and performed some checks on that as well. Yeah, and we don't have any missing temporal, any orphan transaction. So this is the basic model working. The scripts of the code are shared in the island for this model. Let us go to the queries that we performed on this model. Yeah. So the first query that we performed on this model was the problem one. Yeah, so in which client spent the most purchases transaction between 10 to 2 on 12th of the May. So when we perform this query here, our model gives none. The reason for that none is that the purchase dates in our model data is all on the 1st and the 2nd of January 2024, and the query asks us this date, which don't have any purchase on that date, no transaction on that date. That's why this is zero. Moving on to the next problem. Sorry. Yeah. If we move on to the next problem, need to identify the top five clients with the largest negative cash flow. So, after performing the next query, here are the largest five clients with the largest negative cash flow. And let's move to the next problem that we created. So, yeah, uh, we suspect the seller would receive pass-through funds from scam activity. Identify pass on client. So in the wood, we have to identify the client which is potentially having scam activities. So we went into the word, and after running the query, we have found this client to be the one who is passing some fraudulent transaction. So moving on to the problem four. In problem four, we need to detect any pattern of the fraudulent transaction. So we need to trace the transaction of a user, and we need to detect if there are any fraudulent activity in that. So here we are tracing the first transaction, and then in the next part, I am going to check if there are some fraudulent transactions in that. So yeah, if you see this graph, in which I have connected all the next transactions, you can see there are pretty much of the transaction that doesn't make any sense, which can lead to the fraudulent activity of this user. So I'm sorry again here. So that was our part uh, B of the section 2. Moving on to the last part of this section, in which we are performing some graph data science problems. And for the problem 1a, we need to use a heterogeneous graph projection and apply at least two different community algorithm detection. So for this part, there is the heterogeneous projection that we got, and here is the two algorithms that we were community algorithms that we were being asked to apply on that. And let's move on to the next part. For the next part, yeah, for the next part, we need to identify the larger groups which has less than equal to 5 member, which can be assigned as the fraudulent groups. So after some of the diagnosis of the clients and their data, yeah, we got this group, which is GID as 2189, is the largest fraud group that has been assigned with that. And let's move to the next part. It says for the largest group, create a visualization in Neo4j browser Bloom. So unfortunately, I wasn't able to create anything on the Bloom because the Bloom library in my Neo4j, I don't know why it wasn't not working. But these are the visualization for the largest groups of the fraudulent activity that I got here. I have done in the tabular form because the Bloom wasn't working that way that I expected it to work. So moving on to the next part of our problem, we have problem 2, in which a part we need to write a cipher query that isolate cross-boundary transaction transfer where the sender inside a fraud group and the recipient is outside the fraud group, and we return top 10. So in this query, we have two problems. Okay, one was the sender is inside a group, but the recipient is not inside any of the fraudulent group. When we ran this specific case, we got only this one receiver, this one client, and but when we run this query in a way that the sender is in one particular fraudulent group and the receiver is in is not in that particular fraudulent group, it may be another one. Then we got these top 10 receivers in which the sender was in the fraudulent group but the receiver was not in the fraudulent group. So let's move on to the next part. And these are the top recipients outside the sender's fraud group. There we go. Yeah. So I skipped the next three parts of this problem because I was stuck into the second part. I wasn't having the straight projection that costed me a lot of time. So I moved on to the third problem, in which first part we are to build the temporal transaction graph projection. Yeah, this is the temporal transaction graph projection in which we can't see anything, but it says that the projection is being completed successfully. And in the next part, yeah, we apply a link prediction or similarity algorithm, which, yeah, this is the link prediction and similarity algorithm. After applying, we can see there's a lot of similarity between client 1 and 2, which can lead to the potential threat of the, you can say, fraudulent activity. Moving on to the second last question, select the top 5 predicted links with the highest fraudulent likelihood. So in our Neo4j, you can see these are the top 5 clients with the highest likelihood of the fraud. And for the last part, again, we needed to visualize that. But again, timeline visualization, I didn't have a Bloom working exactly, so I did that into the tabular form. And in my tabular form, I just happened to get um, this result here. So that was all my for my assignment of the big data technologies. Thank you so much.